Here's problem number 6 from assignment number 1. We have this problem where we're evaluating this limit as x approaches 1 from the positive side. And this problem involves absolute values. So we're going to just sort of remember that the absolute value function is really thought of as a piecewise function, where it's equal to the opposite when the value inside the absolute value is less than 0, but is equal to just the thing itself when it's greater than or equal to 0. So in this case, when we're approaching 1 from the positive side, that means that the values that are in these square absolute values are considered the positive values. Because if we're just a little bit bigger than 1, the inside of these are just a little bit bigger than 0. Which means that this limit is equivalent to x approaches 1 from the positive side of simply x squared plus x minus 1 over x minus 1. Now let's see if that cleans up at all. Limit as x approaches 1 from the positive side of x squared plus x minus 2 over x minus 1. Now if we get really lucky, we'll get a cancellation. Does this factor be an x plus 2, x minus 1 perhaps? Yes, it does. And of course, lucky for us, these cancel, so now we can apply the limit, and we get 1 plus 2, which is 3. Now, I'm going to do the next problem because they're so similar. Here's problem number 7. And again, we have the same issue, but this time we're approaching 1 from the negative side, which means we're going to be using the negative version of the standard deviation, the absolute value. We'll get the limit as x approaches 1 from the negative side of x squared minus the quantity x minus 1 plus minus 1 over the opposite of x minus 1. Let's see if that magically cleans up anyway for us. X squared minus x plus 1 minus 1 over, I'm just going to keep this as negative x minus 1 for right now. Those two cancel, and if we factor out the x from the numerator, we get x minus 1 over negative x minus 1. Those cancel, leaving us something that looks like 1 divided by negative 1, or negative 1.